Hello, ladies and gentlemen. My name is Amadou Vasco Kone. Welcome to the Ankless Success Live tutorial. This is the Ankless TV. Today will look at the arterial blood gases, which is very important to our Ankless struggle. And I want you to pay attention. Grab your notepad, your little paper, so that we can go through this together and you can have a better understanding. Now, I'm going to divide this into two sections. One section has to do with the regular reading of the ABG's values. The next section has to do with to know whether it is compensated fully, partially, or it is uncompensated. To know that, these are our values, and I want us to remember this value very well. There are more values in the Ankless, but these are the three most important values you're always going to have in the ABG problems. You're going to have the pH, which is 7.35 to 7.45. You're going to have the PaCO2, which is 35 to 45. In some other materials, some other books, it might be slightly different. You're going to have the HCO3, 22 to 26. Now, the HCO3 represent metabolic value. The PaCO2 represents respiratory values. Now, everywhere you see PaCO2 is about breathing, which is respiratory, and everywhere you see HCO3 is about breakdown, which is representing metabolism in our body. Now, the pH tells us whether the condition is acidic, or it is a bacillic condition, or it is alkalosis in short. I want us to look at three things here. Whenever we are given an Ankless question on ABGs with these values, the first thing we want to understand is whether it is metabolic or it is respiratory problem. That becomes our first challenge. And to look at this challenge and know this particular challenge, whether it is metabolic or it is respiratory, we look at two values. The next thing is for us to look at acidosis or alkalosis, whether it is alkalosis or it is acidosis. That's the next challenge. Now, this last portion, we're going to come to it. Let's not even jump the horse. Now, in the Ankless, I had a number line here. The normal value of the ABG's pH is 7.35 to 7.45. Now, but in some conditions, we are going to have a value that falls between 7.35 to 7.45. It is still within the normal range, but we need to know whether it is high or low to calculate or to predict an answer about the question. Take, for example, if you had a pH of 7.48, this pH is high. It is alkalosis because it's high. 7.48 is higher than 7.45. If you had a pH of 7.23, it's low because it is lower than 7.35. So it's low. This becomes acidosis. What if you had a pH of 7.37? Now, 7.37, in a sense, it is not high, it is not low, because 7.37 falls between 7.35 to 7.45. So it is in the normal range. But is it really normal? No. If you look on this normal line, any value of a pH that falls between 7.35 to 7.45 has a high or low prescription or high, it has a high or low point of insertion. So because it is 7.35, from here going left side is 7.40 to 7.35. So this 7.37 will fall somewhere around here, 7.37. If it falls this way, it is acidosis. If it falls from the left going towards the right side, going toward this end of the arrow, it is alkalosis. So because it's 7.37, it is low because it falls below the 7.40 going toward the left side, so it is acidosis. Now, in another instant, if we have 7.42, 7.42 for pH falls between here, but it is high because it falls above the 7.40 line. It is below 7.45, so it falls between here. It will be 7.42 around here. Definitely this becomes a high because it is alkalosis. So let's remember this and keep it. In short, for the pH, to determine whether it is acid or base, we have to use the 7.40. So I'm going to write here 7.40 as the most absolute normal value. Now, we're going to use that in time to come, but not now. So let's go to some few questions here. A patient presented on the unit with the various arterial blood gases. What's the patient's condition? The patient had a pH of 7.38, a PaCO2 of 64, and the patient has a HCO3 of 18. A patient is having metabolic acidosis. B, respiratory acidosis. C, metabolic alkalosis. And D, respiratory alkalosis. What is the correct answer? In this situation, we use what we call the room method. Room method simply means R-O-M-E, room. This room means R stands for respiratory problem, M stands for metabolic problem. So this O and E, O stands for opposite, meaning all of the respiratory problem will be opposite each other in terms of value, and all of the metabolic will be equal in terms of value. What does that mean? That means we look at two values in every given situation. In metabolic problems, because they are equal, the pH and the PaCO2, the arrows will move in the same direction. Meaning when the arrows are moving up, meaning the pH is high, PaCO2 is high, meaning the two arrows are moving in the same direction. This will give us a metabolic answer because the two arrows are moving in the same direction. Or on the other side, the two arrows could also move downward in the same direction. So all of our metabolic answer, the two arrows will move downward or upward. That has made them equal. That's why we say metabolic equal. Now, for respiratory conditions, in respiratory problems, all of our answer, that is the pH, so here and here, the pH will move in opposite direction. The pH and the PaCO2 will move in two different directions. They will not move in the same direction. If they move in the same direction, it is not a respiratory problem, it becomes a metabolic problem. In short, the pH will move up high, PaCO2 will be lower, or better still, the pH will be low and the PaCO2 will be moving up higher. So in a nutshell, the room simply means respiratory equal opposite value, while metabolic will have equal value, meaning they will move in the same direction. Either they move downward or they move upward. In respiratory conditions, the two values will either move in opposite direction, either one going up, one coming down, or vice versa. That's what's happening in here. Now, so let's look at the answer. Let's look at the question. I will use this little space to answer this question. The first thing is we want to look at the pH and the PaCO2 value. Now, in this situation, the pH is 7.38. Is it high or low? We look at the pH here. 7.38 falls within this value. And I said to look at this condition, we look at this normal line. So it is 7.38. Because it is 7.38, so it falls this way. The 7.40 is an absolute value. So 7.38 is lower than 7.40, so it falls on the left side. Meaning this particular pH is low. So we'll have an arrow pointing downward to show that this pH is a low pH. The next thing becomes the PaCO2. The PaCO2, is it high or low? It's 64, and our normal PaCO2 here is 35 to 45. Definitely this PaCO2 is high because it's above 45, so we'll put an arrow here pointing upward. So the PaCO2 and the pH value are not moving in the same directions. They are moving in opposite direction. And what did we say? We say if they are moving in opposite direction here, meaning it is respiratory problem. So in this case, because the two arrows are moving in different direction, this is a respiratory problem. The next thing is we want to know whether it is acidosis or alkalosis. And to know this, we look at the pH. We'll come back to the pH. A pH of 7.34, is it high or low? In this situation, the pH is low because it's 7.38, the arrow is going downward. So because it is low, when it is low, it's called acidosis. If it is high, it's called alkalosis. So if a pH is low, it's called acidosis. If it is below 7.35, it's low. If it's above 7.45, it's high. So this case is 7.38. Taking into consideration the absolute 7.40 as an absolute value, this number is lower than 7.34. This becomes low pH. It is represented by what? Acidosis. So this, our answer, is going to be respiratory acidosis in this situation. Now, let's look at another question under here. Let's see another question here. We have, so our answer is going to be respiratory acid. This becomes our correct answer here. So let's see some other value here. Let's look at another value to answer the question here. Now, we had a patient that had the following values. Patient had a pH of 7.62, a PaCO2 of 20, and an HCO3 of 21. Okay, I'm sorry. Let's look at this condition. Okay. The patient had a PaCO2 of 64 and an HCO3 of 21. What's the correct answer? Is it metabolic acidosis, respiratory acidosis, or metabolic alkalosis, or better still, is it respiratory alkalosis? That becomes the question. In this case, we said normally there are two values that give us the first portion of our answer. Those two values will be, in many cases, will be the pH and the PaCO2. So in this case, the pH is 7.26. Is it high or low? The pH there is high because it's above 7.45. This becomes a high pH, so the arrow shoots upward. The PaCO2, is it high or low? The PaCO2 is high because it's above 45. This becomes a high pH. In this situation, we say room, arrow, O-M-E. If the two arrows are in opposite direction, it is a respiratory problem. If they are in equal direction, it is a metabolic problem. So in this situation, the two arrows are moving upward, meaning they are moving in the same direction. This becomes a metabolic problem. So it is a metabolic problem. Now the next thing is it metabolic acidosis or metabolic alkalosis? What do we look at? We look at the pH. The pH was 7.62. It's high. Because it is high, if it's high, I said, if it's above 7.45, it is alkalosis. If it is below 7.35, it's acidosis. So in this case, it's high, so it is referred to as metabolic alkalosis. Now, so in this case, 7.62 is above 7.40 going toward this way, so it will be under alkalosis, just in case if we stay using this. So our answer becomes metabolic alkalosis. So in this case, this would be our correct answer. Let's see another question here. Now, in this situation, we had a pH, we had a PaCO2 of 38. Now, in this situation, we said we look at the first two, the first two values, the pH value and the PaCO2 value. So in this situation again, the pH is 7.62, is above normal value, so it's high, the arrow goes up. The next one is the PaCO2. In this section, the PaCO2 that represents respiratory system is 38. Is it high or low? It is not high, it is not low. It falls within the normal range because 38. The lowest is 35, the highest becomes 45. So the 38 falls between 35 and 45. So in this case, the PaCO2 is normal. So when it is normal, it cannot be used as a determinant to know the answer for the question. Because it is normal, what we do next, our mind is switched to the next area, to the next system, the HCO3. So because the PaCO2 is normal, so definitely our mind runs to the next system, or we turn our pendulum to the next system, which is the metabolic system. Now, if this system is high or low, meaning this condition is a metabolic problem. So in this situation, it's low because the value is 22 to 26 for the HCO3. So it's lower than the value. So meaning it is low. This becomes a metabolic problem. So in this case, because the PaCO2 is normal, so we do not look at the arrows. We look at the next value. So we'll have metabolic. The pH, is it high or low? It's high. This becomes a metabolic alkalosis because the pH is high. So it's above 7.45, meaning it is alkalosis. In this condition, our answer would be metabolic alkalosis. This would be our correct answer. Now, let's look at our next area to know whether the condition is compensatory or it is uncompensatory. To know this, I'm going to give you a few things here. Let's look at this value quick before we can even leave. Now, when an ABG value is compensatory, this word compensatory meaning it's either fully or it's partially. So if it is fully compensatory, the pH will always be normal. So once we have the first answer and the pH is normal, meaning our answer will be a fully compensatory mechanism. Once the pH is normal, we will have an answer of fully compensatory. If the pH is abnormal, then we look at the next system. To know whether it is partially or uncompensated for, the pH will be abnormal. So in these two conditions, we'll have an abnormal pH, So every abnormal pH will either give us partially compensated or uncompensated. I repeat, every abnormal pH will either lead to partially compensated or uncompensated. And every normal pH will lead to fully compensated. If the pH is normal, meaning there was a full compensation mechanism occurring by the body. If the pH is abnormal, meaning there was a compensation, it's going to either be partially or it's going to be uncompensated. Now, in the case of partial compensation, I wrote it here. The next value is going to be abnormal value. What does that mean? That simply means if it is partially compensated, if it is partially compensated, the next value will be abnormal. What does that mean? So let's say my answer was metabolic answer. It could be acidosis or it could be alkalosis. If my answer ended up in metabolic problem, to know whether this condition is partially compensated, I should look at the next system. That is the value of respiratory, which is the Paco2 value. Now, this Paco2 value, I will look at it. If it is abnormal, if this value is abnormal, meaning it is partially compensated. I repeat, if we have a partially compensated mechanism, to know whether it is partially compensated or not, if our answer is metabolic answer, we'll look at the next system, which is the Paco2, to know whether the value for the Paco2 is normal or abnormal. If it is above 45, it's abnormal. If it is below 35, it's abnormal, and it will be partially compensated for. On the other hand, if my answer ended in a respiratory problem, meaning it was respiratory acidosis or respiratory alkalosis, I look at the next system. Now, because the answer is a respiratory answer, my next system will be metabolic system. So in this system, it's always represented by HCO3. So if I did a question and it ended up in partial compensatory mechanism, to know whether it is really partial and my answer is respiratory, I will look at the next system, which is metabolic. If my answer was metabolic, I will look at the next system, which becomes respiratory. So there are no two systems. If I have one as the answer, to know whether it is partially compensated, I look at the next one as the next mechanism. Let's do a few questions and see whether what I'm saying it makes sense to us. Then we'll know what we are talking about 100%. Let's see a question here. A patient here. So the patient has the following value. Patient has a pH of 7.31. The patient has a PaCO2 of 40, and the patient has HCO3 of 18. So in this situation, the pH is 31 or 7.31. Definitely, this pH is low because it's below 7.40, so it's low. So our arrow becomes going downward. The PaCO2 is 40. It falls between the normal value because we said the normal PaCO2 is between 35 to 45. So this PaCO2 is normal. Now, we said the two first values, the pH and the PaCO2, gave us the answer. But if the PaCO2 is normal, our mind, like I said, or our pendulum is switched over to the HCO3. So because the PaCO2 is normal, we go to the one with the HCO3. If it is abnormal, that becomes a metabolic problem. Now, it is abnormal. This becomes metabolic. Now, the pH is low. It's low, it's acidosis. It's metabolic acidosis. This becomes our first answer. Now, the next thing we want to know whether it is compensated for or not. And we said to have a compensation, we look at the pH. If the pH is normal, meaning it is fully compensated for, like I said in the audio, earlier on in the video. If the pH is normal, it is fully compensated, but in this case, the pH is not normal. The pH is low, so it is not fully compensated. It is either partial or uncompensated for. How do we know that it is partial or uncompensated for? We know this now. Since this is a metabolic problem, we look at the next system, which is respiratory system. It's right here. It said normal or abnormal. It is normal. So because it is normal, like I said, if the next system is normal, meaning it is uncompensated. So this answer will be metabolic acidosis uncompensated. Because the next system in this situation is the PaCO2, because this is a metabolic problem, so this problem is being represented by the HCO3. This is our answer, metabolic. So to know that it is compensated for or not, we look at the next system, which is the opposite system, which is the PaCO2, and it's normal. And if it is normal, it becomes metabolic acidosis uncompensated for. Now, let's see another problem here. Let's say we had a problem like this. The PaCO2 was 60. In this case, it's 60. If it is 60, this pH is low. The PaCO2, yes, we can use it because it is not in normal range. It's high. This becomes high. And the two arrows are moving in opposite direction. Rome, R-O-M-E. Respiratory opposite. So the two arrows are opposite. This becomes a respiratory problem. Now, is it acidosis or alkalosis? Look at the pH. The pH is low. This becomes respiratory acidosis in this situation. Now, the next question becomes, is it compensated for or not? It is not compensated for because the pH is not normal. If the pH was normal, this would have been fully compensated for, but the pH is abnormal. So now our question becomes, is it partial or uncompensated for? Now, we are in a respiratory problem. What do we look at next? We look at the next system. So since we are having a respiratory problem, we look at the metabolic system, which is represented by the what? The HCO3. So is it normal or abnormal? HCO3 is 18. In this case, the HCO3 is 18. It's abnormal because it is lower than 22. If it is abnormal, then we'll have partial compensation. This answer becomes respiratory acidosis partially compensated. That's what happened here. So it is respiratory acidosis partially compensated. Because our answer is a respiratory problem, we look at the next system to know whether it is partial or not, which will be the next system, which is the metabolic system. And this HCO3 is 18 under here, and 18 is low. So it becomes partially compensated for. Let's look at the last question before we leave hold of you. Now, in a case where we are having a pH of 7.40, everything remains the same. Now, in this case, let's say 7.41. In the case of 7.41, the pH here is 7.41. It's above this. So in a sense, the pH is high. PaCO2 is also high. So because the first two move in the same direction, we say metabolically they are equal. From they are opposite. So this would be in the same direction. This becomes a metabolic problem because the arrows are moving in the same direction, meaning they are equal. Now, is this pH in this condition? Is the pH going up? Is the pH high or low? We said it's high because the arrow goes up. If it is high, it is alkalosis. This becomes metabolic alkalosis. The next question becomes, is it fully compensated for? Is it partially, or it is uncompensated for? In this case, if the pH falls within the normal range, meaning it is fully compensated for. And in this session, yes, despite the pH being high on the absolute scale, but on the normal scale, the pH falls within the normal range. It's between 7.35 to 7.45. So this pH falls within this range. So definitely this case would be metabolic alkalosis, fully compensated. So this is how you answer this question in the NCLEX. In short, when you have these problems, you have to look at 3 domains. The first domain is the pH and the PaCO2 to know whether it is metabolic or it is respiratory problem. Now, if the PaCO2 is normal, you got the third system become the HCO3. That's what you do in this case. So thank you very much. We want to say thank you. Stay tuned for more videos. Thank you very much.